Okay, so the main idea behind this video is to basically teach you what all these terms on this left-hand side mean. So that's the goal. If we can name what the first quartile is, the second, the third, the range, the IQR, and the outliers for this number set, then we have an understanding of what measures of center are based on medians, or quartiles, which is a better word for these things. So what we're going to do is we're going to first number these things in order. And that's what you should always do first, is number all the numbers in order. You can see that these are in a random order, but we'd like to get them in a unified order. So we'll start with 21. And as I mark these things, I like to cross them out just so that I know that I've got them all. 37 should be next. I think after that is 58. 70, 73, 74, 92, 94, and 95. The next thing I like to do is count how many numbers I have just so I can know. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So we have 10 numbers. And the first thing we want to do is we want to find the median. And you probably remember how to do this from before. To find the median, you find the halfway point. The problem for this is, with 10 numbers, you have 1, 2, 3, 4, 5 on this side, and 1, 2, 3, 4, 5 in this side. So the halfway point is right here, which that number doesn't exist. So we find that number. How you find that number is you take the average of these two numbers right here. So we're going to take the average of those two numbers. Well, to take the average, all you have to do is you take your calculator, you add the two numbers together, and then you divide by 2. So our answer is 71.5, and that is the median. And again, that's the average of these two numbers here. And what we did to find the average was add the two numbers together and divide by 2, because that's how you take an average. Now we're going to find the first quartile. The first quartile is the median of the first half of this number set. So it's the median of the first half of this number set, which is really easy to find because the halfway point of this number, there's 1, 2, 3, 4, 5 numbers, so the halfway point right here is 37. Then we would do the same thing for quartile 3, which would be the halfway point of these 5 numbers, which was 1, 2, 3, 4, 5. So the halfway point is 92. What a range means is a range is how wide the number set is. So if you want to find out how wide the number set is, you take your first number and your last number, and you subtract them to find out how far apart they are. So the range for this thing would be 95 minus 21, which would give us 74. So the range of this thing would be 74. And IQR stands for interquartile range. So if you think back to what we just said for a range, it's how wide your number set is. So the interquartile range is how wide your quartiles are. So we have a quartile that starts at 37 and ends at 92. So what we want to do is our interquartile range would be 92 minus 37, because that would tell us how wide the quartiles are. And that would give us 55. Again, these are measures of how wide the data is. So it generally measures how variable they are. Are things close together or not close together? The last thing we got to do is if we have to find any outliers. Now outliers, what outliers means is they are the extremes of the data set. It really is something just so far out that you don't think it's realistic. Now if you look at this, our data is pretty wide. And so to figure out if something is an outlier, we use this rule, which if your data is like spread apart, it's less likely that things are an outlier. So this rule takes that into consideration. We use 1.5 IQR. And how you do that is you take your data, or your IQR, and you times it by 1.5, and then we're going to add it to our third quartile and subtract it from our first quartile and kind of see how far that is apart. So I'm going to take 1.5 and times it by 55, and that's 82.5. So we have to figure out from 82, like from our third quartile and from our first quartile, is there any numbers that are 82.5 away from them? Well, you can see when you do this that if you add 92 plus 82.5, you get a really big number. 174.5. So there is no data that's bigger than 174.5. Then we do the same thing with 37. We go 37 minus 82.5, and we'd find negative 44. And we find that no number is below negative 44. So we have no outliers. Okay, let's do this with one more data set. Again, the first thing we're going to do with this data set is we're going to number them. So let's number them out. So we'll get 1, 2, 2. It's next 5, 7, 7, 8, and 10, and 10. And again, we're going to count out how many numbers we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers this time. So an odd number of numbers. Well, that makes it a little bit nicer because now we have 1, 2, 3, 4, 5, and this is the exact middle. So because this is the exact middle, that's going to be our median quartile. We're going to cut this thing in half. So now when we cut this thing in half, we look here and we have 4 numbers on this side and 4 numbers on this side to use for our quartiles. So we're going to find the halfway point for this first set here, or in quartile 1, which the halfway point would be between these two numbers right here. Again, if you don't have a single number that works, you take an average of the things. So you do 2 plus 2 divided by 2, which would be 4 divided by 2, or 2. So for quartile 1, your quartile is 2. We do the same thing for this top portion. We count 1, 2, 3, 4. Again, we have this halfway point right here, which we have to find. We would do 8 plus 10 divided by 2 to find the average. That'd be 18 over 2, which simplifies to be 9. Again, we can find the range of our data set, which is how wide your data set is. It's from 1 to 10. So 10 minus 1 equals 9. So our data set is 9 wide. Our interquartile range is the range of how wide our quartiles are, which would be 2 minus, which would be 9 minus 2, because that's Q1 and that's Q3. So we would get 7. And now we have to check if there's any outliers. Again, outliers are extremes. This doesn't look like it has any extremes, so we're probably going to say no. But again, we can test for if we have any extremes using our 1.5 IQR rule. So we're going to find out how much width is acceptable. So we're going to take our IQR, which is 7. So we'll do 7 times 1.5. So we have 10.5. And again, what you want to do is on the high end, or what would be too high of a data point, it would be Q3 plus this number. And on the low end, it would be Q1 minus this number. So that's how we check. Now in this case, for both of them, our Q1 is 2, and 2 minus 10.8 is a negative number, so we don't have any negative numbers. And on the high end, that's 9 plus 10.5, which is 19.5, and we don't have any of those numbers, so we have no outliers. Okay? And again, that's how you check for outliers, or check for extremas. You take 1.5, times it by your IQR, you get that number, add it to your high end, subtract it from your low end to kind of see what numbers you get to include. If you have any questions, please ask.